Composite area review, problems 18 and 20. We have a pentagon with apothem 3. Find the area. Well, everything that can be labeled has been labeled. So we need the formula for area of a polygon, which is 1/2 the apothem times the perimeter. Well, we need the side length. How can we calculate the side length? Well, what is one interior angle? One interior angle is n minus 2 times 180 divided by n. It's a pentagon we have here. 5 minus 2 is 3 times 180. Which is 540 divided by 5. In this case, an interior angle is 108 degrees. Half of that is this angle here, 54 degrees. What I need is this distance, because 2 times this distance will give me a side length. What trig relationship will give me adjacent side? Well, opposite over adjacent is tangent. So the tangent of 54 degrees is equal to the opposite side over the adjacent side, and I'm going to call that B. Multiply both sides times B. B times the tangent of 54 degrees is equal to 3. Now I divide both sides by the tangent of 54 degrees, and that's going to give me B. What is the tangent of 54 degrees? Well, first I have to check and make sure my calculator is in degrees, and it is. The tangent of 54 degrees, it turns out, is 1.3764. So B is equal to 3 divided by 1.3764. Three divided by 1.3764 is equal to 2.18. B is 2.18. So 2B is 2B or not 2B, 4.36. My side length is 4.36. I have 5 sides. 5 times 4.36 21.8. And that is the perimeter. So the area of this pentagon is equal to 1/2 my apothem, which is 3, times my perimeter, which is 21.8. 21.8 times 3 is 65.4 divided by 2. My area is approximately 32.7 square units. Geometric probability. We didn't spend a lot of time on geometric probability, and the reason we didn't is that it's sort of an odd concept. If I throw darts to this big exterior rectangle, I'm either going to be inside it or outside it. If I'm trying to get a random point not only in the big rectangle but also in the small rectangle, that's going to be a fraction. And this is really interesting math. Okay, first we read the problem. Find the probability that a random point will be in the inner rectangle. Label everything you can think of. This is 10, so this has to be 10. This is 16, so this has to be 16. This is 8, so this has to be 8. This is 14, so that has to be 14. So the probability is equal to the area of the inner rectangle divided by the area of the big rectangle. That gives me a fraction. I am going to want a percentage, so I will end up multiplying times 100. But let's do the arithmetic first. My inner rectangle, the area of that is 8 times 14. The area of my big rectangle is 10 times 16. 8 times 14 is 112. 10 times 16 is 160. 112 divided by 160 is 0.7. To change from a decimal to a percent, I multiply times 100. The probability is 70%.